Hey, it's Mr. K. We're doing a problem for AP Physics 1, a little bit of projectile motion. It's a mathier problem, but it is on the homework. And I do like to put problems on there occasionally that are mathy because you do need to practice your math skills. Even though AP Physics 1 is very not mathy at its core, still a lot of you are trying to go into engineering and doing problems like this. You're going to definitely see this in college in much more complex ways, so I'm going to want you to start off with that here. So the objective here is to get this car. This car is going to be going at some unknown velocity. That's what we want. It's going to land somewhere over here. It goes down 5 meters. It can't hit any of these cars, so it does have to go over a certain distance as well. And we're going to call that distance about 20 meters. Okay, on your homework, I'm not sure what your number is, but these are the numbers that I'm going to use. The first thing that we're going to do is we are going to set up a list of what we know and what we don't know. And because we are traveling in 2 dimensions, I'm going to write down x's, I'm going to write down y's, and our standard initial velocity, final velocity, acceleration, change of time, the change of position x, and the change of position y. Now I'm going to remind you right here, if you are not actually practicing problems like this on your own, and you are just watching me do it all day long, you are probably going to do pretty poorly whenever it comes to a test or a quiz. So make sure you're actually going through the steps of solving it. Pause the video, see if you get it right, instead of just watching and waiting till the end. That's a huge issue with what I see today in class. So looking at this problem, initial velocity is what we want, but it is going at 5 degrees. Now, since we don't really know what the initial velocity is, the only thing that we can really do is work with the triangle, because the velocity is going off at an angle, and this is going to be some horizontal component and some vertical component. And so really, if you imagine this triangle, I'm going to use the ramp over here as part of it too, you're going to have something that goes over and something that also goes up. Okay? And so the over part is going to be Vx, and the vertical part is going to be Vy, excuse me. Alright, so the way that we find this is trigonometry. We're going to use sine and cosine. What I know, as a reminder, is going to be that sine of an angle, this case 5 degrees, is going to be equal to a ratio of 2 sides, opposite, which is Vy, over the hypotenuse, which is going to be V naught, the thing that we want. To solve for this, we would just kind of rearrange, because we don't know what the initial velocity in x or y is, but here we can actually write it down in terms of V initial. Cosine is equal to the ratio of Vx over V naught. And so when you rearrange these, what you get is the initial velocity times the sine of your angle, 5 degrees here, is equal to the initial velocity in the y direction. I'm just going to write that as Vy right there. Same way here, you can move the initial velocity over. V naught cosine of 5 is equal to Vx. And we got some men at work in the background. I'm going to put this over here in the columns. And we have V naught cosine of 5 degrees, V naught sine of 5 degrees, and then we can continue on with our list. So what we know about the x-axis is that the x velocity will not change, so we got V naught cosine of 5. Y velocity, we don't know what the final velocity is, we might leave that blank. 0 acceleration in the x, that's why these two are the same. In the y, we have an acceleration of negative, I'm going to call it 9.8 in this case, because we are doing a homework problem. Just so a reminder, on Mastering Physics, use 9.8 or 9.81, not 10. Time to get there, we don't know. Change of x, we do know. That is going to be 20 meters. Change in y, we also know that. That's going to be negative 5. Be careful about the negative, because downwards, if you wrote negative 9.8, negative 5 needs to go here. And of course, maybe put in some units, even though we will not write them in our actual equations. Okay, so at the moment we are looking for the initial velocity, and we have all this other stuff. And I'm going to do one thing a little bit out of order. I'm just going to look at the x first, and we're going to write down the only equation that the x-axis uses here, which is the range is equal to the initial velocity, which is this stuff, initial velocity cosine of 45, or 5 degrees, because we only want the horizontal component, times time. Okay, and I can actually write down that the V naught cosine 5 times time is equal to 20 meters, because we know that from our list. Alright, this is going to become useful later on, because I'm going to have an unknown with the y direction. If I use the exact same equation for the y direction, the equation I used was the changed position is equal to the initial velocity times time plus 1/2 the acceleration times time squared. Alright, if I use that equation, then I will actually have another one that will have the exact same variables as this guy. We're going to see that when we plug in. So the change in y is -5 meters. The initial velocity in the y direction is actually initial velocity times the sine of 5. The time is, I don't know, plus 1/2. A is -9.8, and I'm off the screen. And delta t is going to be right here. Okay, so what we have here is we have an equation with two unknowns. Initial velocity, t, are both unknowns, but we have another equation down here where initial velocity and t are also the other unknowns. In order to solve an equation, you need as many equations as unknowns in that equation. So we have two equations and two unknowns, so we're pretty good. That's why I use the exact same equation applied here in the x direction. It's only this first part. Applied here in the y direction, it's all of it. Alright, so looking at this, if I can somehow replace time and get everything in terms of v0, then I can probably solve for v0. And this is where it actually becomes more mathy. So I'm not going to slow it down like I usually would, but I am going to work through every single step and try to talk through it, because some people really, really do need to work on their math. So math class begins now. What we're going to do is we need to replace this t with t over here. So I'm going to move stuff over. T is equal to 20 divided by this stuff. This stuff is all multiplied. I need to move it over, so I'm going to divide. Divided by initial velocity cosine of 5. Okay? And we're going to use that and plug it in right over here. I'm going to give myself a bit more room because I have all this page space. So -5 is equal to initial velocity, the sine of 5. Make sure we're in degree mode when we actually evaluate that. Delta t minus, I'm going to pull that negative out right now, 9.8 delta t squared. Okay? And for you, your 5 is going to be a different number, like 7 or 8, something like that. I'm going to take this t and plug it in right here. I'm also going to plug it in right over here. That's why I gave myself more room, because I need to expand a lot of stuff. Here I've got -5 still, equals initial velocity, the sine of 5 degrees. T is all this stuff that I'm going to put in parentheses at the moment. We'll just rewrite it in a second. And if you're decent at math, you don't have to write every single step down, but remember, if you're screwing up and getting the problem wrong, you might want to write everything down, and you might want to make it a little bit neater. So t squared here is 20 over initial velocity that we want, cosine of 5. I'm going to square that. Okay. So some things I can do right now is, let's see, I can go ahead and see that this v0 sine 5 is multiplied by 20 because that's on top. It's actually over 1. And that conveniently, those two initial velocities go away. That leaves me with 20, the sine of 5, divided by the cosine of 5, minus, going to turn that into 4.9. And then we're going to say that we have 20 v0 cosine 5, and that's squared, so it's like saying it's 20 v0 cosine 5 times 20 v0 cosine 5. So the top's going to be squared, so I'm going to say that this is multiplying by 20 squared. The bottom is also going to be squared. v0 is going to be squared there, and then cosine is going to be squared too, and we're going to write cosine squared like this. I'm not sure why people do that, but that's kind of how it is. All this is equal to -5. And we are getting much closer to the actual answer. Let's go ahead and use a calculator to find out what some of these values are. One little trick is that I know that sine divided by cosine of the same angle is tangent. So I can say 20, show you right here, times the tangent of 5 degrees. And I'm getting 1.7498, so I'm going to round that to 1.75. Rounding a little bit is okay. Rounding a lot on working these problems is actually not, because it's a computer that you're typing it into. So be careful with that. I'm going to say minus 4.9 times 20 squared. It's 400, right? And we get 1960. And divided by initial velocity squared cosine 5. This is all equal to -5. Okay, hopefully you're still with me. know this is going to be a longer video. I'm sorry for that. But you do need to know the math. I'm going to move this negative, it was 1.75 over. Negative 5 minus 1.75 gives me equals negative 1960 divided by V naught squared cosine, oh, forgot the square there, squared times 5, or not times 5, but cosine squared 5. Okay, last thing, I really want that V naught, so I'm going to multiply both sides by V naught. And be careful when you do this, because when you do that, you're going to multiply everything by V naught squared to cancel it out on the right side and have it remaining on the left side. That gives us, oh, it's late, let me just do this, negative 5 minus 1.75, negative 6.7, I could have done that, let's do it. Alright, so V naught squared is multiplied by 6.75, and it's negative, equals 1960 negative divided by the cosine squared 5. We are so almost done. The last step would be to divide both sides by 6.75, and so we would get V naught squared is equal to negative 1960 divided by negative 6.75, the cosine squared of 5. And lastly, we would have to get rid of the square by square rooting. These would cancel out, and I get 1960 divided by 6.75 divided by cosine of 5, and we got to do it twice. I'm just going to say divided by cosine of 5 again. And we get a big old number, but we need to square root, which is 17.11. So V naught is equal to 17.11 meters per second to start. And the key here was actually writing our initial velocities in terms of V naught cosine and V naught sine theta. Alright, we will end there. I know this is a more mathy one, but sometimes you do need that help with the math. Feel free to try to go through. Hopefully I didn't mess up. I don't think I messed up. But do let me know if I did. Alright.